I hate guns. Not only because what it does to people, but also because of the recoil. Do you know why a recoil happens? We'll find out in the studio. Hello and welcome. I am Shaleen and today we will discuss Newton's third law. Now for every exam topped, you earn a lot of envy. And this reaction is many times from your friends. So who needs enemies when friends react to your actions like that? But then perhaps you did deserve this reaction, because according to Newton, action and reaction are always equal and opposite. So big action, big reaction. Today we'll see how he explains that phenomena in his third law of motion. Newton's law of motion are three physical laws which provide relationship between the forces acting on a body and the motion of the body. The first and the second law of motion deal with force as a cause and change of motion as its effect. The third law tells us about mutual action between two bodies. To make you understand what mutual action-interaction between two bodies is, let's give you an example. If you sit on a chair and push the wall with your feet, the chair moves backwards. Obviously, the wall is not moving, the chair is. And the harder you push, the more inclined the chair becomes. If you push too hard, you'd fall. Now, you did expect exactly this, of course. But is it really that obvious? From Newton's first and second law, we know that the cause for the chair's motion must be a force. But did you ever wonder where that force is coming from? Okay, here's what it really is. Just as you were pushing the wall was pushing you back in turn. But because the mass of the wall is much more, it didn't move, whereas you did. Now that wasn't so obvious, was it? We know that force is a push or pull which changes or tends to change the state of rest or uniform motion, the direction or shape of a body. Now, if you push horizontally against a wall with a force of 200 newtons, then the wall will push back horizontally against you with a force of 200 newtons. Whenever there is an interaction between two objects, there is a force upon each of the objects. When the interaction ceases, the two objects no longer experience the force. These two forces are called action and reaction forces and are the subject of Newton's third law of motion. So always remember that force exists only as a result of an interaction, and be careful not to confuse this situation with equilibrium of forces in which several forces act on the same object with a zero resultant force. Here, the forces were acting on different objects, that is, you on the wall and the wall on you. The magnitude of force on the first object equals the magnitude of force on the second object. The direction of the force on the first object is opposite to the direction of force on the second object. Forces always come in pairs, equal and opposite, action-reaction force pairs. A variety of action-reaction force pairs are evident in nature. Consider the motion of a flying bird through the air. A bird uses its wings to push air backwards, but a push on the air will only serve to accelerate the air. Since forces result from mutual interactions, the air must also be pushing the bird forward, propelling the bird through the air. The size of the force on the air equals the size of the force on the bird. The direction of the force on the air, that is backward, is opposite to the direction of the force on the bird, which is forward. For every action, there is an equal in size and opposite in direction reaction force. So it's action-reaction force pairs that make it possible for birds to fly. Therefore, we can say every action applied by a body on a second body results in an equal but opposite reaction by that second body back on the first body. I mean, you just have to push me to find out what the reaction is. Now we know that for every force, there is an equal and opposite force. Newton's third law states, in any interaction between two bodies, the force applied by the first body on the second body is equal and opposite to the force applied by the second body on the first. Essentially, this means for every action, there is an equal and opposite reaction. Consequently, when a horse pulls at a cart, it means that the cart is pulling at the horse with the same force. Now in that case, the cart should stay where it is, shouldn't it? You may log on to topperlearning.com for a detailed answer to that and many more questions, and also revision of this topic. Meanwhile, I'll be back in a jiffy. Don't go away.